Just a little test. With multimodal transport, we also have cost savings, and this is the #1 factor. The savings resulting from these advantages are usually reflected in the through freight rates charged by the multimodal transport operator and also in the cost of cargo insurance. Establishes only one agency to deal with, and by this has to deal with only the multimodal transport operator in all matters relating to the transportation of his goods, including the settlement of claims for loss of goods or damage to them or delay in delivery at destination. Reduces cost of exports. The inherent advantages of multimodal transport will help to reduce the cost of exports and improve their competitive position in the international trade. Okay. Now we have some examples of multimodal transportation, such as we have a transshipment from land to sea and then again to land. And the example is that an empty container is picked up from the line's container yard and is trucked to shipper's factory for staffing, and thereafter the FCL is trucked to Singapore. Then ocean transportation follows from Singapore to New York, then truck from vessel to railhead to New York, and rail from New York to railhead to Chicago, and then finally from Chicago railhead to consignee's warehouse. And above you can see an example of multimodal transportation. Another example is the transshipment from sea to air and then back to sea. This is particularly applicable where the route combines large distances via land and water, and where transit time is really important. This combines the economy of sea transport, and the speed of air transport is becoming increasingly popular in several international trade routes. The economics of this combination mode usually meets high-value items like electronics, electrical goods, computers, and photographic equipment. A more complicated example is from rail to roads, inland waterways, and finally to the sea. Common use when goods are moving from an inland center to the seaport in the country of origin, or from the seaport to an inland center in the country of destination. Here we have the mini bridge example that involves the movement of containers under through bill of lading issued by an ocean carrier by a vessel from a port in one country to a port in another, and then by rail to a second port city in the second country. The mini bridge offers a consignor through container rate inclusive of rail freight up to the final port city in the country of destination. The railways are paid at a flat rate per container by the ocean carrier, and this system is in operation on certain routes covering the trade between the United States and the Far East, United States, Europe, United States, Australia. Land bridge. This system concerns itself with shipment of containers over land as a part of a sea-land or a sea-land-sea route. In this case, the railways are paid a flat rate by the ocean carrier who issues the through bill of lading. This system is in operation now for the movement of containers on certain important international routes, such as between Europe or the Middle East and the Far East via the Trans-Siberian land bridge, and between Europe and the Far East via the Atlantic and Pacific coasts of the USA. Roll-on, roll-off. This mode is very common in European Union trade and combines different means of transportation, sea and road, and is used most often with new automobiles, which are shipped by sea and then simply driven off the vessel to the importer's warehouse. Heavy and over-dimensional cargo is also suitable for ro-ro transport. It is also used in short sea shipping, and that's why in Europe is really used very often. Light abroad ship. This is a really expensive option, and it is necessary to check on the availability of the special handling facilities necessary in the ports of destination. Piggyback. The goods are packed in trailers and hauled by tractors to the railway station. At the station, the trailers are moved onto railway flat cars and the transport tractors, which stay behind and then disconnected. At destination, tractors again haul the trailers to the warehouse of the consignee. Piggyback 2. This is a system on unitized multimodal transport land transportation and combination of transport by road and rail. It has become popular in Latin American and European countries because it combines the speed and the reliability of rail on long hauls with the door-to-door flexibility of road transport for collection and delivery. Summarizing the advantages and the examples, in actual practice, several other combination modes may be used depending upon the trade routes, transshipment points, and the availability of different modes of transport. New infrastructural developments are being proposed the world over to create a seamless flow of traffic, e.g. the Channel Tunnel linking England and France, the Øresund Bridge linking Sweden and Denmark. And as these projects have become reality, so the flow of traffic changes. Other changes, such as global warming, pose the potential for new routes to open up via the Northern Sea between Russia's northern border and the North Pole. And finally, an operator should have the knowledge and the skill to organize the transportation through different modes of transport. He should be aware of what is happening in the areas of technological development, political stability of countries, congestion of routes, or mergers of operators. Since the function of the multimodal transportation derives from the needs of the shipper, he must be able to offer a service which covers a wide geographical area, either through an in-house branch network or by means of reputable agency arrangements. Well, now we'll have another chapter which is called modal split. It's really important when we have multimodal transportation. And what is modal split? Modal share or modal shift is a traffic transport term that describes the number of trips or more common percentage of travelers using a particular type of transportation where more than two are available. In freight transportation, the term can refer to the percentage of volume or mass. Modal shift describes a change between modes. It usually means a desired or actual increase in the proportion of trips made using sustainable modes. In the general case, where m transport modes are available, the probability of choosing a particular mode, say mode I, can be calculated using the below function, where when you have to choose between two modes or routes, we can use a simple mode of the above model, which is below the first function. The parameters on this model are mainly the CI, which is the generalized cost. Fi, which is equal to Pi, is the probability of frequency of mode I to be selected. Pi, capital, is the price for the mode I, the freight rate and the other costs. Ti are total travel time of mode I, and ABC are specific parameters for each mode. K is an indicator for the learned modes, and lambda is a constant factor, always positive, which is really changes the percentages, as we can see in the next slides. Well, an example for this presentation is the case of the Northern Sea route, which was till now ice-covered and impassable, but because of global warming, it will open a new trade line. It extends from 2,900 nautical miles. The climate change in Northern Sea route is more significant than other geographical latitudes, and IPCC models predict ice-free Arctic during summer months until 2100. But we already know that ships operating in this area. The first complete crossing was a few years ago, in 2009, by two German commercial vessels. The benefits of choosing the NSR is that this route reduces distance by 25%. The trip duration is also reduced by approximately 10 days. Another factor is that, is that when choosing the Northern Sea route, we have low piracy risk, and because of that, we have lower insurance costs, which affect the generalized cost. Vessels also avoid Suez congestion. We also know that congestion in Suez is increases year by year. In the map, you can see the comparison between the two main lines connecting East with North Europe. The drawbacks for this selection is that ice class certification is mandatory for vessels. This route is available only for during summer months. Are we okay? We may also have some restrictions for the ship, the size of the ship, which is affected by the troll. And navigation license is hard to obtain, and high port use and taxes we may have for crossing Russian seas. Very high investments are important for ports and infrastructures to be made. Another option for this for transferring goods from Asia to Europe is the Trans-Siberian Railway. You can see the main line in the map, and it is, as you know, is the longest railway network in the world, with a length of 6,500 miles, and connects Russia and some parts of North Europe to the Far East. Now, Trans-Siberian Railway is connected with German railways and operates between Germany and China. Operate flights between Germany and Russia and China. Okay, sorry. The advantages are that Trans-Siberian Railway offers the shorter connection between Europe and Asia. The trip duration is also reduced than the ship duration, and train operates on electric power produced by hydroelectric or geothermal energy, making it the cleanest mode of transport. The disadvantages are that train has significantly smaller capacity than vessels, and it's not compared because a train can transfer more from 100 TEUs versus vessels that can carry 9,000 of TEUs. And we also have problems when multimodal transport is needed, because some parts of Trans-Siberian Railway are incompatible to other railway networks. The scenario examined was a trip from Hamburg to Shanghai. In the table you can see the time, the trip duration in days. For using only sea, only train, and the northern sea route via sea, and finally the air transportation. Below you can see the freight rate and the generalized cost produced by the formula we show you a few slides before. And in the final line here, you can see the percentage of of trade transported by this time of mode. And for now, maritime transport via Suez Canal remains the best and most preferable choice. Well, the outputs, depending on the parameter lambda, we show you in the first slide of this presentation. Parameter lambda expresses our wish to choose the mode I, and as lambda reduces, differences between three options become smaller. In this graph, you cannot see the percentage of volume of cargo transported by air, because, as you can see in the table in the previous slides, the cargo transported by airplane was significantly small. Well, we show you in the introduction that when you have to choose between airplanes or more expensive choices, it is more applicable for cargos really expensive. And as you can see in the graph, when cargo value increases, the value of time increases as well. And for cargos between $10,000 and $160,000 per TEU, we have the Suez choice remaining the most preferable choice. But when the cargo value increases more, choosing a more quick transshipment becomes preferable choice. Here, Trans-Siberian Railway offers this choice. Conclusions. In most cases, maritime transport remains the most preferable choice, even though congestion in Suez really makes things worse, and even though the piracy has increased the costs. Trans-Siberian Railway is preferred for expensive cargoes, as we mentioned a minute ago, and Northern Sea Route is not a competitive choice under these existing circumstances, but we think that Northern Sea Route really soon will offer a really competitive choice. Thank you for your attention.
We also have a second topic with Irini.
Yeah, but we should have a break.
Yes, now we will have a break. Next topic is in about half an hour. Okay.
Okay.
And it's about ports, infrastructure, and strategies for door-to-door logistics. Okay, thank you for the moment.
Any questions? Okay, thank you.
Okay.
Thank you. Καλή κάμερα.
Sure. Ακούω εγώ αυτό. Σήκωση, τις κάνουμε νόημα. Τις κάνουμε νόημα να φύγεις.
Να πάω βαθιά.
Σήκωση, ακούω εγώ αυτό.
Α, ωραία.
Καλά.
Good morning. Again, now we have the second presentation about port infrastructures and door-to-door logistics. Can you hear me well? Okay. Ma acούς? Let's start with the presentation. Αν δεν φαίνομαι καλά, παίζουμε. Hello again. Θα μου γυρνάς εσύ. Please give us a couple of minutes. Προχωράει. Μπορώ να το έχω δηλαδή. Ναι. Well, this presentation has to do with port infrastructures and strategies, so we can have complete door-to-door logistics. Here we have the contents of the presentation. First, we will have a small introduction, then we will be familiar to port categories, and therefore a case study is examined for the port of Rotterdam. And finally, we'll have conclusions. Okay, then here we also have the basic economic equation, which is that trade is equal to wealth, and for economical, obviously, reasons. And international trade is a win-win situation because both parts of the transaction get rewarded because it is a very attractive situation. But we also need, sorry, την προηγούμενη. Πώς πάω πίσω. Okay. For a better trade market, we also need agreements, but that is a bit difficult to be achieved among nations. That was harder in the past, we can say. Now, with globalization and European Union, many problems have solved, and we have better situations to get started a trade. Well, trade also tries for multilateral agreements amongst nations for the reduction of tariffs and tries to supervise and liberalize international trade. The purpose of this is that very high rates of trade growth. International trade is directly linked with GDP and oil price, and as Stopford mentioned, 1% increase in GDP means a 2% increase in maritime trade, and we can see here that we have a double increase when in trade when we have also 1% increase. Okay. And increase in oil price means a decrease in international trade, and we have faced that in years before, and this sets barriers to world trade. Ports, as facilitators and sustainers of the waterborne trade, ports are the conduits whereby the benefits of trade are realized and distributed to the port's hinterlands. We have many benefits from good ports and lands, such as direct benefits associated with support services to ports, and that would suffer immediate cessation if port activity were to terminate. Secondly, induced benefits occurring to the regional community associated with expenditures arising from the direct benefits. Indirect benefits generated regionally as a result of expenditures by firms that are directly dependent on port activities. And finally, benefits occurring to manufacturers and distributors arising from their exporting and importing businesses using the ports. Impact of all the above is that we have more jobs, more wages, businesses, revenues, and taxes that help the economic of a country, directly or indirectly. Well, here we have the benefits from a US deep water port system categorized by direct benefits, induced benefits, indirect, and benefits to exporters, importers, and etc. We can see that this is quiet. We have 6% of total referring to jobs. Well, when we have direct benefits, induced benefits, we have 8% jobs, 22% wages for millions, and 26% taxes. You can see that it's a huge amount for incomes. The indirect benefits are in the factor of 4%, and exporters and importers are the winners of these games with over 90% benefits in $1 million. You can see that it's obvious that if we hadn't trade, we probably be poor. And to the other slide. For port organizational structure, we have seen that emergency measures such as entry of specialized carriers in maritime transport were taken for better efficiency, and these changes improved the organization of ports. Service ports, we have some examples of organizational structure ports, and we have here the main four. The first one is service port, which is publicly owned ports, the full range of port services, including cargo operations, and are carried out by the port authority. The tool port, where infrastructure and superstructure belong to the port authority, but in transition states, between a service port and a landlord port, where landlord port has to superstructure investments of private sector. Fully privatized port is characterized by a practice initiated in the UK where many state ports were sold off to private owners. In a privatized port, a private company owns the port land, operates the port as a private venture, and may also effectively be the regulator. So we can face all these types of organizational of port organization in Europe. According to World Bank and favorite models is that of the land port, because cargo handling is a 24-hour function and requires exceptional adaptability. Secondly, support services such as warehousing, engineering services, container management are most efficiently carried out by organizations that compete in an open market. And finally, states' interests are protected through retention of control of the port's infrastructure and of the regulatory function by the Port Authority or another state agency, or it can achieve maximum positive impact in terms of numbers of people employed, wages, salaries, businesses, revenues, and taxes through the high levels of overall efficiency. Infrastructural developments in a port is the increased cargo Okay, let's begin the slide again from the beginning. The infrastructural developments in a port, increased cargo throughput requires greater capacity, larger and deeper ships. We have seen a few months ago the new bigger ship of Maersk Line, which cannot be served in any port. Special cargo facilities for special carriers, e.g. RoRo. We saw that in the presentation an hour ago. Compliance with regulations, improved technologies in the intermodal network, and systemic change is the urban expansion. A port makes investment in infrastructure to remain viable. Categories and finance of port infrastructures. Basic port infrastructure is the maritime access channels, breakwaters. It is fundamental, long-lived, and does not earn revenues directly. It often receives partial funding from the state or of local authority. Port infrastructures such as quays, jetties, and piers, aids to navigation, meteorological systems are necessary for the Port Authority to manage the port in a safe and secure manner. It is therefore normal for the Port Authority to finance them from its revenues. Port superstructure, paving and surfacing, terminal lighting, parking areas, warehousing. These superstructures complement the commercial port operation concessionaire or lease. Port equipment, cargo handling equipment and tags. Cargo handling equipment is normally financed and operated by a terminal concessionaire or lease in a landlord port. Tags are usually contracted or owned by the Port Authority. Let's get introduced by 10T funding for port infrastructural developments. What is 10T? Is Trans-European Transport Network, and it's a support funding program from EU for transport infrastructural developments, which is established under the EC Treaty. Knowledge of 10T funding for port infrastructural developments is particularly important for small to medium ports because many of them appear to be unaware of the availability of such funding. It supports studies about transport infrastructural developments not exceeding the 50% and works in transport infrastructure aged 20 to 30%. Criteria for this funding is the relevance the maturity, the impact, the compliance with EC law and policy, environment, quality, and common interest and profitability. Targets competitiveness, social and economic cohesion, job creation, and between 2007 and 2013 has been spent about 8 billion euros. Corporate social responsibility in ports. Ports have negative public image. And why is that? The reasons are perception. They are centers of moral and political corruption, depressing industrial zones, pollution centers, disaster areas, destroyers of natural environment. What is really important that is to try to change this perception image. And how can we achieve that? By engaging wider community, good public relations, identification with port-related events, and use of socio-economic studies. Demonstrate the value of port We have this noise because connection and disconnection of our users. Well, the target is to demonstrate the value of port to community and the state. Environmental concerns and port activities. Το κλείσαμε. European Community concerns regarding environmental protection and reflected of 4 directives. We hope it's okay now. European Community concerns regarding environmental protection and reflected it on 4 directives: wild birds, habitat, water framework and noise. Habitat Directive establishes a European ecological network known as Natura 2000. It covers a substantial area, almost 1/5 of Europe's land and water, with special protection areas. Environmental legislation, such as Natura, can financially affect port development projects. Assessing in alternative solutions, greater cooperation from Port Authority, positive initiations, such as the model of the port of Göteborg in Sweden. Before expansion and investment plans, environmental legislation should be taken into account. There is often a conflict between public interest and financial benefits and environmental protection. The strategy of EU for maritime transport from 2009 to 2018 was summarized in increasing the efficiency and productivity of all European seaports, balancing the need to increase investment capacity with due respect for the environment, modernizing the ports network by, among other things, simplifying administrative procedures and making increased use of information technologies such as e-maritime, guaranteeing fair competition between ports, addressing the human aspect with the new framework for social dialogue. We have a first case study for Dublin Port Company. Okay. Dublin, with its port as center, was a significant Anglo-Saxon city with military, judicial and trading power until 19th century. Act of Union seat of government in Ireland moved to Westminster. In 1867, Dublin Port and Docks Board takes over, replacing Ballast Board. In 1996, Harbours Act, it is renamed to DPC, Dublin Port Company. With Harbours Act, control of key ports removed from government, and commercial freedom to port to operate as a modern consumer-oriented service industry. Businesses strategy includes summarized in customer-focused, capitalize on new businesses opportunities through evolving, innovating, and upscaling staff. Liquidate non-core activities and competition inside ports. Operational tactic has dealt to do with agreements for guaranteed level of clients. Personal training, 3% of payroll invested in educational programs. And finally, DPC training and management techniques have helped them to establish a global reputation for being innovative and sustainable, and have contributed to port's successful joint venture operations. Well, these are providing university scholarships for members of the local community, assisting local drugs prevention and rehabilitation group, RDRD, Resent and District Response to Drugs Project, sponsorship of local football and rugby clubs, and sponsorship of a major local art exhibition, provision of assistance to communities abroad, international CSR. This was a social program to promote the role of the port. Global businesses, management operations, Indonesia, and the training program of United Nations in India and Cambodia. 2007 data gives us a sense of 193 employees and 70 million turnover and 54 million tons of imports and exports, servicing by the Port of Dublin. Conclusions are that ports are essential to maintaining and instigating growth in the national economy and have a direct effect on GDP. Ports are, however, undervalued by the local and national communities, which they service investment by the port in a corporate social responsibility program. The organizational structure within the port is of crucial significance to its efficient and successful operation. The European Commission recognizes the importance of ports to the survival of the common market and in the interests of sustainable transport. Excuse me. Ports need to be aware of the potential impact of their activities on the surrounding environment and should explore all alternatives in consultation with interest groups. Training and upskilling of all staff is vitally important to a port's success. Recommendations from this case study are that port management authorities should critically evaluate their current management practices in accordance with the World Bank classification. Competition should be fostered between companies engaged in operation within the port, with the management of the port being the preserve of the port company. Port management authorities should undertake a competency skills audit which encompasses all levels of staff. Corporate social responsibility should not be a mere tokenism. Port management companies and companies operating within the port should avail of substantial European support funding to supplement their businesses' development strategies, such as from TEN-T. Port management authorities should pay special attention to the new policy documents releasing by the European Commission, which may provide opportunities for port development. Then, from a small port such as the Dublin port, we jump to the first port of the Europe. This is a case study of the port of Rotterdam. Here you can see the port area, which starts from the sea and continues inland with this line. Well, here we can see the top world container ports for 2011. First was the Shanghai, and then follows the Singapore and Hong Kong. After all the Asian and Middle East ports comes Rotterdam. Here we can see the top 20 European container ports for 2011, and obviously Rotterdam is in the first place, followed by Hamburg and Antwerp ports. Well, here we have a change. Regarding the port of Rotterdam, we have economies of scale for both sea and land sides, strengthening of hinterland connections, and we have it has been made attention to modal shift, which is essential for processing the growing freight flows. We have also growth in volume and overcapacity of ships, increased cooperation and integration of services, and new additional terminal capacity in Europe. Excuse me. Here you can see nautical accessibility for the port of Rotterdam, and there we have no draft restrictions or tidal windows for the port of Rotterdam. Here you can see Hamburg, then Antwerp, Amsterdam, and finally Rotterdam with 19 meters draught. Also, you can see the sailing time pilot to berth, and for Rotterdam is only 2 hours. You can understand how important is this factor, while in the second one, port in the Europe, you have to wait for a half a day. What makes Rotterdam a global hub? All major shipping lines have weekly services calling at Rotterdam. We have connection with Asia and Middle East, 24 trips per week, with Africa, 2 trips, North America 11, South 13, and finally we have also connection with Australia with 1 trip per week. We also have a high ratio of first-class port of call services, large number of short sea and feeder connections, which implies with multimodal transportation. Here we also have look to what makes Rotterdam a gateway to 350 million customers. They have excellent barge connections with Netherlands more than 200, and with rail connections with a total of almost 500 connections. Multimodal choices that offers the Port of Rotterdam are railway connections. They have 160 kilometers of dedicated rail freight line of Rotterdam to the German network. Performance for 2011 was approximately 510 trains per week. In 4 hours from Rotterdam, a container can be transshipment to German's rural area. They also have inland terminal network and is more reliable and efficient connection to the port, improving accessibility to the port and reducing CO2 emissions. Operating of the port has also some other benefits, such as they work paperless, working partnership with private sector, tailor-made solutions. They operate 24/7. They support a single window concept and non-intrusive inspection. It is also a project about port cooling, a complete cool cluster in the Walhaven area. It is the state-of-art at cold store operations, cross-docking facilities, high-frequency shuttle connection, and LCL consolidation point. And they also will start construction in the next year, which is planned to operating in the middle of 2015. Sorry. Further on, they also going to improve accessibility for ULCS. They also plan widen from 2055 to 310 meters, and work currently in progress and expected to be completed by in the middle of next year. Conclusions from this case study. is that we does not need only the geographical state to make a port significant. It's a combination of all trends for an efficient transshipment and providing innovation such as port cooling and strategic cooperations. Thank you for your attention.
Okay, so now we finish the second topic of today's presentations. We have one more. I will do the next topic in about, I don't know, half an hour. We'll have a half an hour break and we will come back to continue. Okay, thank you.
Questions?
Sorry, is there any question about the last topic? No? Any question from UPM, Genova? Okay,
Thanks a lot.
thank you. You can email your questions later. Hello. We are starting the next topic. Well, I'm Thanos Papas. I'm a PhD candidate here in National Technical University of Athens. I will talk to you about a learner string eco profit model, and I will talk to you a little about the optimization process, the environmental and financial optimum selection, and concerning the operational profile of the company. So let's share the screen with my presentation. Hope that you all see the presentation now. Well, if anything, if you have any questions, you can interrupt me with raising your hand or by chatting. Well, as I told you, you can't hear me well. Yes, because sorry, I forgot to open the microphone. My fault. Just a moment, please. Okay. Well, as far as the calculation, the optimum financial. Okay. Okay. Thank you, Genoa. The financial and environmental optimum solution under various scenarios, depending on the operational profile of the company. This is achieved by developing a generic cost model methodology that aims to minimize the total operating cost by using genetic algorithms in optimizing various predefined attributes such as the operational speed of each vessel in each line of the network. Well, the finalized model that I will describe you now could be easily applicable for liner shipping companies for optimization purposes of liner networks and as well for simulation and examination of possible scenarios. Well, so for the optimization process, there are three basic steps that we have to follow. First of all, we have to design the network using expert judgment, how many ports, which ports in which distances, to analyze the cargo flows, current state, future trends and vessel portfolio. Several feasible routing scenarios are also assessed. The aim is to deliver a set of possible network alternative designs capable of meeting transport service needs and constraints. As far as the second step is concerned, we have to study each scenario with each combination of the values of the decision variables, and finally choose which one of them is the best, the optimal solution. This can be done by just enumerating, or for a bigger problem with more variables, we can use genetic algorithm tools. We solve the corresponding cost function minimization problem, and we find the applicable optimum solution. And the step 3 is just to find the optimal solution. A learner system is consisted by a portfolio of vessels deployed at a set of routes. For example, we can have a main and a feeder line, and we decide which vessels of the fleet will operate in which of the lines. Well, so very well. Is, no. Well, this is some steps for the optimization model. The first thing we have to do is to provide all the possible values to the decision variables. The combination of the decision variables will have as a result to our objective function the total cost of the operation of this network. After that, we have to rank all these results and decide which one of these is the best one for our purposes. After that, we can repeat the same procedures with changing the combination of some crucial input values. I will talk to you after for as far as these crucial input values are concerned. It's about the fuel cost and the operating cost of the system that are some constants to our problem. Well, the decision variables are the speed of each vessel in each line, the number of vessels deployed in the route. Forgot to tell you that the speed is have some constraints depending on the technical characteristics of each vessel, and we can use the vessel speed with a step of half of a knot. The number, also a very important decision variable, is the number of vessels deployed in each route. For using this variable, we use some binary variables that take the numbers of the value of 0 or 1, and it depends on if a certain vessel operates on a certain line. And finally, there's the idle time for any ship, that is between the two consecutive sea voyages at each line. So I told you about the speed. So now we can turn to the crucial variables I mentioned before. These are the canal and the port fees, the fuel cost at the port and during the sea voyage, and some various ship costs on an annual basis. These ship costs are the maintenance cost, crew cost, chartering for chartered vessels, and annual cost for owned ships based on the ship value, depreciations, and cost of capital of the company. In order to compute these costs, various time components must be accurately estimated, like idle time in each line, voyage time in each line, loading and unloading time of vessels at each port for every line, and also mooring and unmooring time. Well, now these are the rest variables of our problem. We can talk a little about them. First of all, we have the origin and destination flows of the TEUs from one port to another. You can imagine that like a two-dimensions table, having all the combinations between all the ports of the line. Moreover, the next variables are the TEU's cargo that will be unloaded at each port in each line, and loaded and unloaded also. We have the capacity of each ship that is expressed in the TEUs. The loading and unloading cost at each port, how much does it cost to load and unload every TEU. The fixed cost of an assigned ship J per round trip at each line. The chartering cost for chartered ships, the freight rate, and the freight, that's all. So we are having some major assumptions in our problem. We have to take demand as a deterministic flow of TEUs per unit time, and it has to be independent to the level of the service. Liner system and carrier satisfies the demand of transport services. Liner system operates in a constant frequency according to pre-announced schedule. and consumption per vessel is a function of speed. I think it's important to say here that idle time and the frequency can change a little bit so that we can have zero idle time and we're able not to use the idle time if we adjust the frequency. But because in every line the frequency has to be the same, it's better that we have more possibilities using also idle time and frequency. So here we have some graphs that shows us that the fuel consumption is a function of the speed. Well, now as the cargo flows are concerned, we have the two-dimensional table I mentioned before. These are all the ports of the line 1. This is our main line. And what does this table show to us? That in Qingdao, annually, we have this number of incoming TEUs and 0 of outgoing. So a vessel that operates in this line will at first be loaded, actually this has to have to be opposite, as I see now. So this number of TEUs leave from Qingdao. So the vessel that first arrives in Qingdao is loaded with this number of TEUs. In the second port, Busan, it will, no, these are correct. Okay. So in the second line, in the second port, it will unload this number of TEUs and it will upload this number. So it will have on the vessel this number of TEUs, and this actually shows us how many TEUs will go and leave from each port and how many TEUs will be loaded in each vessel during the way in the network from one port to another. So liner shipping system, actually it's a network. It includes many lines. Each line we can say that it could be a subsystem of the main system. So when it comes the time to calculate the total cost, we can just add the subsystem's costs. Now, in order to calculate the total cost, we have some equations sets. We categorize the main costs of the operation of the network. We have port-related costs, ships-related costs, and some costs that has to do with all vessels, no matter if it's chartered or owned. Well, in the port-related cost, we have the loading and unloading cost per TEU in each port. For ships-related cost, we have owned vessels and chartered vessels. And actually, costs are some other variable operational costs: the consumption at port, the consumption at sea. For chartered vessels, we have the time charter cost, and for all vessels or chartered or owned, we have the inventory cost. If we add all these separate costs, we have the total cost profit for the operation of this network. It's this equation with all these variables that I just described you before. Here we have a flowchart diagram of the cost profit optimization model. Actually, it just shows us how this model works. We have the inputs here, which are mostly the constant cost that we know from the start. We have the decision variables that each combinations will differ the actual result of the equation. And for every combination of these decision variables, we will choose the best one, the one that gives us or the best financial optimal solution, or the best environmental solution. Here is, inside this box, it's the procedure that will be followed in order to find the optimal solution. This could be some enumeration for little problems with little decision variables, or for bigger problems with more lines or more vessels in the vessel portfolio. We can use genetic algorithms who will help us to find the optimal solution. After that, we can change the crucial parameters I told before, and these ones will give us some different solution, optimal solution. After this, now we have some results. As crucial parameters, we have the fuel price at $400 and the inventory rate at 7%. These are the 10 best cases. The best one has a total annual net profit about $34 million, and these are the CO2 emissions. And in order to achieve this solution, the optimization model found that we should use 20.5 speed knots for speed going and 15.5 for return, and we should use 5 ships. So the rest are the rest results. It's not the optimal. Now we have this graph that shows us the CO2 emissions depending on the annual net profit. We see that we have the financial optimal solution is somewhere around here, and the environmental optimal solution is somewhere around here. We can see the difference between the object, if our object is to be environmental, and if we just want to have an optimal financial, the best net profit, annual net profit. This is the same, but we just changed the inventory rate, this crucial parameter. Now we took it as 0%, and you can see that the whole optimal solution changes like this. Now we have both solutions using 0% inventory rate and 15%. It shows the different values of the decision variables used in the problem, here and here, and you can see the difference in the annual net profit and in the CO2 emissions. So besides the decision variables, it's very important the crucial parameters like the fuel price and the inventory cost rate. Now we have an example changing the other crucial parameter, which is the fuel price coefficient. We can see with 200 euros per ton and 600, how does the values of the decision variables change, and how the result of the objective function for the annual net profit and for the CO2 emissions also change. Using stable the inventory cost coefficient rate about 7%. And now it's a diagram that shows us all these different uses of the parameters. Now, actually, I think I described the model in total. If you have any questions, you can ask me by chat or by raising your hand. As the conclusions are concerned, we have to say that this research I described tries to answer some basic questions on liner shipping companies, like what's the optimum operational profile for financial and environmental, using financial or environmental criteria in various economic situations and operating profiles. Also, a multi-way what-if analysis is carried out aiming to examine the profitability of a simple case of a linear company and reveal the optimal operation profile, studying the vast number of different scenarios depending on the different values of the crucial parameters. So, linear shipping profitability is found to be extremely sensitive to a large number of parameters, to adjustable decision variables, to non-adjustable variables from the financial environment. These are the crucial parameters. The fuel cost is a volatile variable affecting profitability, eco-friendliness, and optimum speed. The higher the fuel cost, the lower the optimum speed, and more vessels are required in order to comply with demand and frequency constraints. So, as you understand, all is about the cost of the fuel. Inventory cost parameter has a complex impact on optimum operational profile. It affects mostly the leg with the higher utilization factor, pushing the two legs to operate in different speed. As far as the inventory cost parameter is concerned, I want to say that here we say that time is money. So the more time the TU stays on ship, the more money is lost for the company that wants to transfer this TU. So if the inventory cost rate is high, the vessel should operate on a higher speed. That means most fuel cost, and most total cost, operating cost for the line and the network. As a general conclusion, the higher the inventory cost factor, the higher the operational speed, as told you, but also the gap between them. In the real world now, operations demand for transport services is showing elasticity dependent on various important parameters that define the level of service. By choosing low quality for transportation service, this can lead to low cost and emission operation, but for sure it will also be low incomes operation due to customers and freight averting to more appealing alternatives. Well, this was the whole presentation. Thank you for attending. Do you have any questions from here, Athens? No. From UPM, Genoa, Simne, Angel? No. So thank you for attending today's course here in NTUA. We will continue tomorrow with our next course. The time is at 11. The topic is shipping economics. So I hope we'll see you again tomorrow. Thank you very much. Bye.